Welcome back, everyone. We're live again, and we'll start with our official NIM tutorial, part 3 by now. I think it's a good idea to just start every stream with a little bit of, maybe 15 minutes of learning something new. So before I start, as always, feel free to subscribe, feel free to like the stream or other videos if you like it. It helps a lot. And if you're watching on Twitch, you can follow me there. And you can always just say hello in the chat or ask a question, suggest something, both Twitch and YouTube. And also on YouTube, video is always available after the live stream, so we can ask questions there too. Even though the live stream is gone, I'll be always happy to, respond or whatever it's about. So yeah, that's it. Let's begin. So last time, during last stream, we finished with going through procedures and the difference between a function and a procedure. And now we can get back to iterators, where, the fun begins. So iterators. Let's return to the simple counting example. So we echo counting to 10, and we have the for loop, where we get I, n, count up from 1 to 10, including 10, and echo I. Can a count up proc be written that supports this loop? Let's try. So we have proc count up from A to B with an integer and returns an integer, right? So we do whatever, the res is A. So I guess that's our response, the one we start with. And then as long as the response is lesser or equal to B, it will just keep going, which is return the result, increase by 1. Return a result, increase by 1. And this will just count up. Of course, this won't work, right? However, this does not work. The problem is that the procedure should not only return, but return and continue after an iteration has finished. This return and continue is called a yield statement. Now, the only thing left to do is to replace the proc keyword by iterator. And here it is, our first iterator. Yep, it's that simple. We just have an iterator. The rest stays the same. And the only thing is that we yield the result so that it returns that value. And then when the count up is asked again, it just continues until our little, condition is no longer met and the whole loop ends. All right. Iterators look very similar to procedures, but there are several important differences. Iterators can only be called from for loops. Oh, you can call them manually? I thought that we saw something about maybe a little bit different iterators. Iterators cannot contain a return statement, and procs cannot contain a yield statement. Okay, so you actually can't have the return. You have to finish. Okay. Iterators have no implicit result variable. Okay, that's why we're defining the our own one here. That explains it. Iterators do not support recursion. Oh. That's too bad. I guess you could call other, procedures through that. I wonder to what extent they don't support that. That's very interesting. Because, nothing is stopping us from calling a simple, a proc inside here somewhere and that proc would use for loop with a count up. We'll try that in a second. Iterators cannot be forward declared, but because the compiler must be able to inline an iterator. Okay, this restriction will be gone in a future version of the compiler. Possibly. So it cannot be forward declared. Okay, so okay, I see. So if we were to add a proc that uses count up, we couldn't do that, but you could forward declare it. Okay, we'll try it in a second. However, you can also use a closure iterator to get a different set of restrictions. See first class iterators for details. And I guess that will be different article. It's in the manual. Okay. I guess that will be something we need to read at some point. Iterators can have the same name and parameters as a proc, since essentially they have their own namespaces. Oh yeah, because we can use iterators only within the for loop. You know, nothing's gonna collide because you can't really use the proc in the same way. Therefore, it is common to wrap iterators in procs of the same name, which accumulate the results of the iterator and return it as a sequence, like split from the stringutils module. Okay, makes sense. So how about we grab some of this code? Let's grab that iterator and let's figure it out, because I am curious how far those limitations go and what kind of error message we're gonna see. So we have our iterator, right? And we should be able to do echo counting up, and we'll do for I and count up from 1 to 10, right? And we do echo I is, and we'll just add the index I in there. Let's just make a different name. Let's call it my count up, just so that it's not colliding with the existing count up, okay? All right, there we go. So if I'll save it and run it, there we go. Counting up all the way from 1 to 10. So what if I wanted something where it counts, I don't know, there's a recursion there or something. Let's say something where it says I is 1 and then 1 again. It says 2 and then it goes 1, 2, and 3 and then 1, 2, 3, 4 and 1, 2, 3, 4, something of that sort. So let's say that we're gonna add another parameter, which will be root, and it'll be boolean, okay? And we'll say that this is we're iterating here, it will be our root, as in the one that uses the recursion. And normally what we would do here is that we would yield that result, and then we would want to we would want to have this whole thing go on again. So we would do for I and my count up, and we do from A to that result that we just had, and we say false because it's no longer false. And we would need to do if root, right? Only if it's root we're gonna do that, or we will get like infinite one. And we do yield I or something of that sort, and that should be it. So now it's unhappy because recursion is not supported in iterations. See? But what if we're gonna make a proc my count up wrapper, okay? Huh. It won't work because proc needs to return the whole thing. Yeah, so you can't even wrap it. But what if it would have the same thing? Just call it simple. Can you use one iterator from the other iterator? My count up sim. Wait, this wouldn't even exist here, right? Because this is our simple count up. So we would do my count up simple. Okay, because it's a different iterator, and now we can. Okay, so you can use iterator. One iterator inside other iterator. It just can't be the same one. And you can make a cyclic situation, even if you wanted to, because you cannot. There's no forward declaration, so you can't make this. I mean, you can't make the my count up to be available inside the my count up simple to call. Okay, that works. So if we're gonna run the counting up now, let's just get rid of the root, and I will just always do that. We'll simplify the code a little bit, and let's run it again. Oh, type mismatch, count up. Yeah, we don't call it that way anymore. There we go. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, and it keeps going until 10 is basically 10, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So at least we can use one from within the other. Okay. That makes sense. So that's it. I guess we won't learn about the first class iterators. We can have it as a separate read some other time. So let's take a peek at basic types. This section deals with the basic built-in types and operations that are available for them in detail. So if our booleans, okay, NIM's boolean type is called bool, and it consists of the two predefined values, true and false, and conditions and while, if, elif, and when statements must be of type bool. And the operators not, and, or, XOR, and all those normal ones are defined for the bool type. The and or operators perform short circuit evaluation. Yeah, short circuit evaluation means that when you have this condition here, okay, p is nil, and p.name isn't xyz. So if this is true, then also this will be checked. But if this one is false, it knows that the AND operator doesn't need to bother even checking for the second one, because, hey, we already figured that one out. We know it's false. There's no need to suddenly execute the other one. Okay? Characters. The character type is called char, whatever. Its size is always 1 byte, so it cannot represent most UTF-8 characters, but it can represent one of the bytes that makes up a multi-byte UTF-8 character. The reason for this is efficiency. For the overwhelming majority of use cases, the resulting programs will still handle UTF-8 properly, as UTF-8 was especially designed for this. Character literals are enclosed in single quotes. Characters can be compared with, your standard equality operators, and the $sign operator converts a character to a string. Chars cannot be mixed with integers. To get the ordinal value of the character, use the ORD procedure. Converting from an integer to a character is done with the CHR procedure. Okay, simple enough. I think we already knew most of it. Let's look at strings. String variables are mutable. So appending to a string is possible and quite efficient. Strings in NIM are both zero terminated and have a length field. A string's length can be retrieved with the built-in len procedure. The length never counts the terminating zero. That's important. Accessing the terminating zero is an error. It only exists so that a NIM string can be converted to a C string without doing a copy. Okay. The assignment operator for strings copies the string. You can use the ampersand operator to concatenate strings and add to append to a string. So the ampersand doesn't modify a string, it returns a new string, while add actually modifies the existing string, the one on the left. Strings are compared using their lexicographical order. All the comparison operators are supported. By convention, all strings are UTF-8 encoded, but this is not enforced. For example, when reading strings from binary files, they are merely a sequence of bytes. The index operation, if string and then we get I, means the ith character of S, not the ith unit character. So, if you have UTF something, it will be multiple characters. So you can just extract that specific, emoji. It will just return one character that represents the emoji, while the emoji is built from multiple ones. And a string variable is initialized with the empty string. What else? We have integers. NIM has these integer types built in. Int and 8 and 16 and 32 and 64. Uint as in unsigned int 8, 16, 32, and 64. The default integer type is int. Integer literals can have a type suffix to specify a non-default integer type. So yeah, so basically if you don't want to do the colon and 16 or whatever, or int 8, you can literally do y is 0, this apostrophe, and i8 to signify that this is i8. If you wanted uint 8, I guess it will be u8. Most often, integers are used for counting objects that reside in memory, so int has the same size as a pointer. The other thing that I want to point out is that you can actually define your own suffixes to describe your own kind of literal that you have like a proc that decodes the string on the left and spits out the value that should be assigned to it, which is kind of cool because you can do fun stuff basically. Okay, so okay, so int is the same as a pointer. So I guess that means that on a 64-bit system it will be int 64, I presume. The common operators are plus, minus, multiply, division, modulus, and basically comparisons. Okay. And they're defined for integers. The and or XOR not operators are also defined for integers and provide bitwise operations. Thank you that these are not those double weird characters. Left bit shifting is done with SHL, I guess shift left. Right shifting is with the shift right operator. Bit shifting operators always treat their argument as unsigned. For arithmetic bit shifting, ordinary multiplication or division can be used. Okay. Unsigned operations all wrap around. They cannot be led to over or underflow errors. Lossless automatic type conversion is performed in expressions where different kinds of integer types are used. Okay. However, if the type conversion would cause loss of information, the range defect is raised if the error cannot be detected at compile time. Okay. Floats. NIM has 3 floating point types built in: float, float32, and float64. The default float type is float. In the current implementation, float is always 64 bits. Okay. Float literals can have type suffix to specify a non-default type. Again, we have the what do you call it? Asterisks? No. Apostrophe. F32 or F64. All right. The common operators, and we have again the same, just we don't have the modules and we don't have the integer division, are defined for floats and follow the IEEE 754 standard. Automatic type conversions in expressions with different kinds of floating points type is performed. The smaller type is converted to the larger. Integer types are not converted to floating point types automatically, nor vice versa. Use the toInt and toFloat procs for these conversions. Okay. Okay. And let's finish up with type conversions. Conversions between numerical types is performed by using the type as a function. Okay. Yeah. So we can basically say that, hey, we want to hold int32, so you can do 1, which is, I guess, just int, dot int32. So it's the same as doing this. Okay. Or this, we're converting a character to int8. Here we just said that it's float, so it will implicitly convert itself. And something like int 2.5 would round down to 2 because it always rounds down. And then we have some which takes int x and y and int z, so it will just add them up after converting float and int8 and int32 to the common int. Okay, makes sense. All right, so tutorial time is done. Let's get back to our CommonFS. Today I'll try to talk a little less. I don't know, maybe there's somebody, I don't know what people enjoy more. When I'm talking nonstop, which I presume will give some people a headache, or I talk less. I don't know. Right now there are no viewers, but if somebody's watching on YouTube later, hey, please let me know if you prefer me to talk nonstop like I usually do, or prefer a little bit more of a quiet thing where I'm just sometimes explaining something when I encounter something weird or whatever, or if somebody says hello in the chat or something. Okay, so what I'm gonna do for now is I'm not gonna create any more methods right now or procs operations to perform on our file system. I'm just gonna go and go to our little library here, and I'm gonna continue with writing tests because as painful as it is, they need to exist. And they need to be correct, because I think the plan would be to, when I have those tests completed, I would like to figure out to make it so that the tests are all written inside the CommonFS library. but at least the portion that requires, creating the actual, like here, test requires an instance of FileSystem, which, at least for current directory tests, that would work. But for something where we have the tests and I was create directory, if we have, a not implemented file system, just, a new file system, I would just call, create directory isn't implemented, it just throws an exception. So none of the tests would pass. So what if we would be able to kind of turn all those extra tests into a separate proc or something that they all live and are defined in CommonFS, but then when we have, let's say, OSFS in a separate library, or somebody comes in and I think I'm gonna write a implementation of this interface for S3 bucket or something, then they could actually, instead of writing all the tests themselves, which for basically every library you would need to write or copy and paste basically the same set of tests. What if the library itself comes with like basic checkup to make sure that you implemented the interface properly? Because this is like, an example of how to use the interface or abstraction or whatever, how to use CommonFS. And the only place where there is anything different with the code is here, where we're assigning what the file system is in the setup. That's the only spot where we're actually using something from within the OSFS library. Everything else is just, code straight from CommonFS. So I think that would be a cool idea where, I want to write a library for, different implementation of that abstraction. And you can just add one line to basically check if whatever you wrote is complete and everything is fine. And the same thing, the base library upgrades, tests are upgraded, and therefore, you're still sure that however the library will be used will be, it'll be working for everyone. So I really like that idea. I reached out on Discord on NIM Discord and already got a few ideas how to implement that, but I'll do that after I have, the basic set of tests for what we currently have. Okay, so what can I do now? Let me think. So we implemented the checking if directory exists, create directory, and tests for the current directory, right? We have for current directory where we set it and read it. And then for the get absolute path to, we also make sure that, things are behaving as they should. Okay. So I'll look in here, CommonFS. Nothing to test here. Current directory tested. Setter tested. This tested. Create directory. Tested. Directory exists. Tested. Okay. So now we need to test the remove directory. But do we have it properly tested? I'll go to create directory. Should throw an exception when creating directory with the same name as existing file. Okay, so for now, we'll just find out if it throws something. I guess at some point, I don't want to do it today. We'll need to come up with what error should be, raised in what situations. So if somebody wants to implement, excuse me, somebody wants to implement this specific, implement our abstraction, we want to expect the same error for the same type of situation. Yeah, but for now, any kind of error is fine. The method definitions itself already restricts us to what kind of errors could happen. Okay, and it's not throwing in this situation. Okay. Gosh, why am I getting so sleepy? Like really, really sleepy for some reason. Alrighty, so was basically now remove directory. That's what we need to test. So I will maybe just get rid of the license. I don't care about that right now. Let's copy all that, the setup and tear down, and maybe the first test. Okay, and we will be testing the remove directory. I'll make text a little bit smaller so it's easier for me to navigate. Should be still readable. Okay, so let's create new test for directories. And it will be remove directory tests.nym. Let's paste what we have here. It will be remove directory. Hello, viewer. We have somebody watching on YouTube. Or we had. Now it's showing that it's me. Go figure. Okay. So remove directory. And let's do remove directory tests. And this way in temp, it should be fine. Okay. So we have that, and we still need the file system, and we still need to create the directory, and a teardown. I will still remove the directory no matter what, because we don't know if it's, how it's gonna work. So it fails. It does not fail if the directory never existed in the first place. Perfect. So we don't check it, delete it if it exists or not, whatever, and everything that was inside after every test. So for remove directory, we should have something like should remove directory using an absolute path. Okay. So we should first define that this will be our test directory. We'll use the absolute path to basically create it. Okay. But we'll just use the create directory just like we used here, and it'll be directory absolute. Okay, so we just create a directory, and then using our file system, we can remove it. Remove directory. What do we have here? Let's put it on the side. File system and just the path. So absolute path, directory absolute. There we go. And we just check if the directory exists, and it should be not. Okay. Another test should be very similar. Using a relative path. Let's make a directory 2 and remove, and we should be able to use the relative path, right? But that means that we need to do fs dot current directory is, and we can use the test directory path. Okay. And we're gonna give it the directory relative. So because FileSystem knows that already, it should detect that, hey, this is not an absolute path. Let's concatenate and work from the current directory. Okay. And that should be the same. Okay, let's save it. We have 2 tests already. So as far as I know, we can go to our tests and add it here. I want my Copilot with me because it makes things faster. Remove directory tests. And how did we run it? Like this, run test task. Yep, both work. But let's just double make sure that the file actually exists, that the directory actually exists in the first place, so that we're not doing anything wrong in the middle. So this is good, and after we created it, still exists as well. Still all good. Awesome. So what else could happen here with directory removal? Let's do like to do. I mean, let's do test should remove an empty directory, right? Test should remove a directory of files. Should remove directory of subdirectories. Let's just make all 3. Just super make sure that everything works. So let's get another directory here. We'll call it 3. We create it and make sure it exists. Okay. And that's an empty one, right? So then we just remove it and make sure it's not there anymore. While files, we need to do some fancy stuff. After, create that directory and some and a file inside it. So it will be, we did file thing somewhere, right? Creating a file. How to search inside the project. Open and close. There we go. Open a file and close it. And that creates an empty file. So it will be let's call it let file path is directory absolute, and we combine it with test file txt. Sure. Let's just call it file txt if it's shorter. And we just do file path a string, write, close. We can even do write And we could do hello there. Okay, just extra fancy one that we have file with actual data. And what after that, we just remove it and check if it was removed. While for the third one with the subdirectories, we want to get to the created directory and the file inside it. And then we want to create a subdirectory and file inside of it. So subdirectory path will be something with subdirectory. There we go. And create that directory. Make sure it exists. And the file also like that. And then we'll just, test. Okay. Well, let's call it number 4. What is wrong here? Directory absolute. Check if it's what's wrong where? I guess it's not wrong, it's just thing doesn't like it. Because it all looks good. Let's try to run it. Okay, expression right over has no type or is ambiguous. Oh, because we open the file and write doesn't return a file. Okay, let's skip writing. And it doesn't matter. A file is a file. Okay, let's save it and let's try to run it. And now it's all good. All the operations work. Good. So can we have any errors here? I guess we should tackle the situation where the directory basically doesn't exist. If it doesn't exist, it should assume that it, test should not, or what it should not, or what is the proper way to describe it? Should not throw, okay. Should not throw an error if the directory doesn't exist. So we have another path and it will be basically, hey, oh, we're checking if it exists and it shouldn't. And we just call it, remove it anyway. And that should be fine. And we can even call it twice. We do fs.current directory is, sure, test directory path and remove directory and directory relative. So we'll check for both because why not? Okay. And then we should also test should throw an error when trying to remove a file. That's the thing. That let's do it even without an extension. We have a file and a path to it. Okay. We create that file, make sure it exists, and we expect catchable error when we call remove the directory while giving it a file path. Okay, let's make sure it works. Wow, another test that just perfectly works. I'd say surprising. I'm not used to that, at least in NIM. Many other languages that we find, but in NIM is just Oh, wow, okay. What just happened? Never mind. Okay. Is it everything that we need to test? Because the thing is that next thing to tackle will be, you know, things like, oh, you don't have permissions, or this happened, or that happened, and uh, I don't know how to even test it properly. I will have to have different process that's running on some different user to do all that. I don't think I'll be bothering with that, to be honest. If something goes wrong, just throw one of the errors that makes sense and we'll call it a day for now. I just need to think to the whole thing, work in some way before I can consider it. What would you call it? Before I can consider it worth going into such effort as figuring those more difficult things out. So let's commit our changes. Do I have Git Kraken running? I don't. So Git Kraken. Okay, we don't care about quick fun. So we have create directory tests. Just remove license. What do they call it? Remove license string comment. I don't care about that right now. And then we have, excuse me, test. Remove directory proc. Okay. Bam. Push it. And our library is just a little bit larger. Feels good. Okay. What's next? I'm still talking a lot, aren't I? I'll try my best to just stop talking. Alrighty, so next will be CommonFS. We did all those, so now we need to move to file operations. Get file handle. How do I even test it? Because it just removes the file. I guess I need to make sure that it returns some kind of file that makes sense, I guess. Okay, we've got our test file. Now let's grab the previous one and we'll be able to get something going. So we don't need OSFS for that. Yeah, that works without that. And we have suite CommonFS dot get file handle. Yeah. Copilot is having trouble figuring out what language we're writing in. I think I'm gonna play myself some light music. And hopefully you won't hear it. Let's see OBS if you can hear the music or not. Looks like you can, so that's good. I'll enjoy it. You won't because it's normally music, it's not stream music. Yeah, the thing with those streams is that occasionally I get one person watching. They see new language and they're like, I don't know that because barely anybody knows the language. And then because of that, everyone just instantly checks out. I don't know, having music would help, but I don't know. I really don't know how streams work. I just stream it so that I actually force myself to work on stuff. So let's get to work on stuff. We said that we have this suite. We set the test directory again and set up and tear down. Same old, same old. But test directory path. Sure, let's have something, right? Or we don't have to. We can just do whatever we want over there, in there. So for setup, we don't even create a directory. We just say new file system. Okay. And we have a new instance of the file system. For teardown, there's nothing to tear down. We'll just do discard. Okay. Because I think if I won't have that, I'll be unhappy about it, right? Yeah. So, get file handle. It just grabs the... it just creates the instance of file, right? Yeah. Where is it? Here, get file handle. It just needs to return a file and we give it the file system and a path. And all it does, it basically makes sure to create a file that has an absolute path, and that's it. Okay. So should return a file handle for a file that exists. But then what? Then why some of the characters just highlight? What the heck? Because we're aware that this is not running with an implementation, so we shouldn't be even able to check if the file exists or it does not, or whatever. And this is not functionality that whoever writes the library will even touch. So no, we don't even check if the file exists or not. It just should return a file handle with correct fs and path. Okay. So we create a path, dot path, and let's say that handle is fs get file handle, and we just give it the path. Okay. And do we have access to handle dot? Let's see how we define file. Both fs and absolute path are unavailable. Okay. We would need to define some proc or something that actually returns the value, because we don't want them to be readable. We just want to be able to get them. Okay. So here we have file operations. Proc absolute path, and we'll just do self file, and we'll return a path. Returns the absolute path the provided file handle points to. Okay. And we just return self absolute path, and that's it. No variables, no nothing. It won't be modifiable. Okay. And that needs to be exported. And then we can do the same one, proc, I guess fs, right? And it'll be the same thing. Returns the file system object the file handle belongs to. Okay. That's it. This way we have those values here, those fields, wherever it is. Those fields now are still read-only because we provided proc, because the actual, what do you call it, fs field and absolute path fields, they're all private. So when we decided to just create the where'd it go? Oh, here, yeah. When we decided to create the procs for those, they will be purely getters. And I guess it shouldn't matter too much if we're doing something else. Can I should do something like inline? Okay. Because it's so short that we should suggest inlining it at all times. A little C kind of thing to do, because we're just giving a hint to the C compiler. Same thing go here, I guess. Or not. We or ignore those. I don't know how complex they will be. Although, no, because they don't call much code. They just call to a method. Okay, let's keep it in line. Sure. So during this get file handle, I guess we're gonna test also the fs and absolute path just to make sure everything works. So we do check fh path, absolute path is the path. Okay. It should return a file handle with correct fs and path given absolute path. Okay. Because then we can try the relative ones. Too bad I can't share music. All the copyright laws make life less fun. Guess I should just be able to do that, right? With space. And our test should be the same thing, just given a relative path. How do you refactor in? Because you can refactor here. VS Code sucks. I wonder if we could reuse something here. fs dot get absolute path to relative file path. That should equal, right? So we can reuse our functionality rather than hoping for this thing. Okay, let's see if it runs. Okay, both passed. Good news for testing trivial code. So yeah, we give it a path. It shouldn't even check if it's a directory or whatnot. It just gives that. And we give it the absolute path. We give it file system. and it keeps those. I guess in the future we can also get something to extract the name of the file or extension or whatever, those simple little things. But we don't have to worry about it now, right? Sure, let's do it. Name. And that should return a string, name of the file, including the extension. And I believe this was already defined in the whole standard paths, as far as I know. So let's get to our docs, duplicate them. Where was it? Standard library. And that was in generic operating system services. Paths. There we go. Extract file name. Extracts the file name of a given path. The same as name and extension. Oh, okay. Should we even bother trying that? Because we have the path. Anyone with the paths can just call it. But at the same time, I would like to have those nice little helpers, because it will be just really handy. Just get right there. Writing code will be so much easier. So name will be excluding the extension. Okay. Then we can just copy it, make some like ext, returns the extension of the file. Dot. We'll check on that. And that will be file name. Sure. File name, that will be returns the name of the file, including the extension. Okay. So we know that it will be return self.name. And ampersand self extension. So I guess the ext should work. Change extension. Oh, split file. Okay, split file splits the file name into directory, name, and extension tuple. Directory does not end in directory setup unless slash. Okay. Okay, if path has no extension, extension is the empty string. Okay. Okay. All right, so we split file. For now, we can implement it where it just does it every time we call it. So what was it? Split file. Okay, we tuple. We do skip. Then we'll have name. Oh no, we don't need to do it here? Oh yeah, let's do it here. An extension will be self.absolute path, and that will be split file. Yeah, and that should return it. So we can basically do name and extension, and that should work. That mismatch, one is path, one is string. Which one's path, which one's string? Name is path. What the heck? The name will be a string. Okay, that works. So we can kind of do the same thing here. The name, ignore the rest, and we just return the name. While for this one, we just return the extension. Sure, that should work. We just have 3 more things to test. So maybe we'll rename it from get file handle tests. Let's rename it to something like file handle tests. Okay. We'll test the get file handle. That's sweet. And then we have file dot and what is it? Path helpers. Sure. I just call it that way. Dash path helpers. Okay. We do the same thing with tests and stuff, setting it up and whatnot. Name should return the name of the file, right? So if our path is this, we create the handle. The name should be test. Okay. Temp somewhere, and we do some file dot or whatever, txt is fine. So that should return it. And we can just get one more variant of that. Path 1, handle 1, path 2, handle 2. And let's do something else here. User repos, or I don't know, let's call it Whatever, something stupid. There we go. And should be exactly that. So next will be test. Name should be empty string if path string if there is no name in path. Okay. So now the first one will be just like that. There's nothing there. It's absolutely empty here. And the other variant, again, this will be 1 and 1. The other one should be where we have, let's say, this thing. But it will be the get or get ignore. Everything's 2. Okay. There are 2 scenarios where it should be empty. Yeah, and that's it. Either empty or there's something for the name itself. So the next one will be test extension. Should return extension of the file. Okay. So we have some file at .txt. It should be .txt. Here it should be .pdf, and I believe dots are included. Okay. Next one will be should be empty string if there is no extension path. Okay. And this shouldn't be it. Let's say there's nothing. There should be no extension as well. Okay. This is better. Let's just make sure that this is still properly called. Get file handle tests. Yep, that's it. Oh, can't open the file. Files get file handle tests. What do we name it? File handle tests. Oh. Undeclared field extension. Ah, yes. Then check the AI code. Instead of that, it will be ext. Save. Try to run it. Declared field extension. Where is it? Oh, here as well. Well, name should return the name of the file. The check failed. Okay. Should be test while we got some file. Name should return the name of the file. And then the empty string, there should be no path. No name in path. Oh. Let's look at the documentation. Split file. Splits a file name. There does not end in their separator unless it's BAM. Extension includes the leading dot. If path has no extension, if no directory. Yeah, if path has no file name component, empty strings. Okay. So something isn't working here. Name should return file name of the file. So that's the first one. And this wasn't test. Oh, duh. Okay. And here, I guess it returned somewhere. Oh no, it was dot get ignore. I guess if the file begins with dot, it doesn't consider it to be just an extension. If I'll do dot txt, will the same problem happen? Yeah. So I guess that's not the use case. If we have just the extension, it will consider the whole thing to be, you know, the name of the file. Okay. Good to know. But if we'll just give it an empty path, it should be just fine. So let's roll with that. We can just say that we have our path 3, and that will be whatever, home user / get ignore, and that handle 3 should be that name. So we'll just add a comment. Hidden files. Aren't treated as extensions. Okay. Therefore, if we would have the same situation here, extension should return extension of the file. So if we will do something here where we have dot get ignore, right? It should return nothing. For if I were to do ext. Let's see if I'm right. Yes, everything works. Good. So now we have the last variant, which will be file name, which should be both name and an extension. Yeah. File name should return the name of the file with extension. Okay. So we can do some file, and we should get the whole thing. For manifesto, we should get the whole thing. For test file name should be empty string if there is no name and path. Okay. So let's do that as well. We have this and that. They both should be empty. Then we have file name should be name of the file if there is no extension. Okay. So we have this, and let's also do dot get ignore, or I don't know, dot ignore, whatever, or get keep. There's so many different variants. Okay. And there's no situation where there's just an extension. Okay. So we run it, and everything is fine. Awesome. Makes me happy. So we have those 3 tested. And yeah. We know that file handles are created properly. Progress. Okay, so let's go forward. I think at some point we're also gonna create like a, we have file handle. We're gonna make a what do you call it? Directory handle. Okay. This way we'll be able to do similar things just with a directory. And again, this is something that the implementation will be able to use, but doesn't have to implement itself. So that should make life easier for both users of our library and the people who implement it. So hey, win on both sides. I think I'm gonna also start like a series of streams. Maybe Friday streams instead would go for game development. That could be another thing, but game development I think will be either Godot with C#, because that's something I'm familiar with, but learning game dev after not doing a lot of stuff in game dev for last few years, with learning a new engine would be difficult enough. It's difficult enough on its own without also trying to use different language or whatever. Alternatively, maybe Unreal Engine, but I know that sometimes it, for some reason, just crashes my computer. I wonder if it's something with my graphics card or with the power supply. Don't know. So, yeah. Don't know if that's gonna work. Alrighty. So let's move on with testing the file operations, right? Create file. We need to make sure that exists and that returns the file and whatnot, all the good stuff. So let's get rid of this one. We'll create a new one. Let's already name it properly. It will be create file tests. Okay. And we can create it. Create file tests.nym. And what we can do here is not file handle tests, something more like this, because this will be an actual proper implementation of suite OSFS create file. Okay. Let's copy this so we make sure that we have the proper file. This will be create file tests. And we have FileSystem. We'll create directory for the whole thing. Remove it after each test. So what should create a file with the given path? Yeah. So let's make sure. What's going on with the YouTube? YouTube just constantly has some problems. Complains about one thing then another. Don't know. Should create a file with the given path. Okay, so let's do the similar thing where we create relative and absolute path. This will be less of a directory. Let's go with test file 1, okay? And then, well, we just create a file. If we'll just do that, I will give an absolute path. An absolute path, okay? I guess we shouldn't use articles here. Okay. So this should create a file. Right now it's not complaining because, you know, it returns a file, but it says that, hey, it's optional. We use the thingy here, the fancy thing. What was it called? Create file discardable. See? So we don't have to worry about the return type. But in our case, we'll do let file and we'll save it. So if we create it, we do check and we do, what is it? fs dot file exists and we give it a name. That should work. And then file path should be the same as this. And yeah, that should be it. And the same thing should be create a file with given relative path. Okay, so we do basically copy it, but the difference will be, let's just add txt, sure. Just so it looks nicer. Okay, so we have both. We create file and we use the relative, but first we need to make sure that our file system current directory is test directory path, okay? And then we check if the file exists and if the file path is the same absolute value. All right, I'm gonna run it to make sure everything works so far. Error, undeclared field path. What am I doing wrong? File dot absolute path, okay? And that should fix it as well as in here. Okay, that works. So what else should we do? We should have an exception if we want to create a file where a directory already exists, right? Let's just see what it suggests us. Should create a file with the given relative path and a parent directories. Yeah, that's another thing. What if we give it a path where there's a bunch of subdirectories in the middle that don't exist? Should it create those directories or should it not? That's something we need to check, but so far should throw an error. An error if a directory with the same name exists, right? So we'll do test file 1. And we have the same thing here, absolute. So we first create the directory. And then, no, we're not doing that. We do expect catchable error. And we just give it the code, which is literally that. Okay, it just should throw an error. Okay, absolute path. Yeah, exactly. That's good. So another one was should throw an error if the file with the same name exists. Should not throw an error if a file with the same name exists. That's the thing. So we don't have create file here. We can only use what we had in some other place. Yeah, it should throw an error, and we have this to create a file. So let's create the file. And that will be the directory absolute. Let's do it .txt, and let's just call it as number 1, 2, 3, and 4. Just in case to have less conflicts. Yeah, file absolute. We just create a file there, and we should just have the normal thing. File. This will be the directory absolute, and everything should work. I'm still naming directory. I should call them path. So let's get all the directory relative and do path relative, okay? And all the directory absolute, and let's name them path absolute. Okay. Can I run it? That file absolute. Oh, path absolute. That's it. Okay, everything works. So I'm gonna take a short break, and then we're gonna continue. All right, we're back. So, what else can happen when we create file? Throw an error if there's a directory. It shouldn't when there's a file with that name already. I guess there will be cases where it should throw an error if, yeah. Let's look at the default NIM implementation so we keep things close to NIM in the NIM world. If we'll go to the OSFS, where we implemented the create file, it does open. So opens a file named this and that, okay? Raises an IO error if the file cannot be opened. So that doesn't give us much of an explanation. And we just touch the file. That's it. So given that, let's assume that if the parent directory doesn't exist, it will fail to create the file. So should throw an error if parent directory doesn't exist. So the relative path will be some directory, or like missing / test file 5. Okay. Absolute will be this whole thing. And yeah, the thing doesn't exist, so we don't need to remove it. What the heck? Okay. And expect catchable error if we create file with a path here. And that's it. Because that directory doesn't exist. Let's see if it actually works that way, or it will magically create a file. Okay, it should throw an error if parent directory does not exist. What kind of error do we get? Can I just do that and echo E dot message? Remember, that's how it worked. Undeclared identifier E. Don't remember. Where did we handle some errors? In the OSFS again. OSFS. As E. Oh, because this is expect rather than accept. That's why. Okay, no worries. We'll test that later. But yeah, it throws an error, so that's good. And there does not exist. Yeah, and that's all that comes to mind right now. So we have the file creation finished. Let me actually commit some of those things because we're not doing that as we go, and that's a bad thing. So first one will be file handle tests, right? And let's get that file handle tests. And for that, we actually need to add those procs to CommonFS. So will be test file handle test file handle operations. Okay. Also implement name extension and file name procs. Okay. So that will be the first thing. The other thing will be create, test file creation. Okay. And bam. So after file creation, we need to check if the file exists. Okay. So far we're already doing that, so I guess it works to some extent, but hey, it would be nice to actually know for sure. So let's do include file/file exists tests. Perfect. And we can get the directory exists tests as a template. And we need to create it also. Create new file exists tests.nym. Okay, things are starting to move a little bit faster. Good. So we paste that and OSFS file exists. No, test directory path. Okay, this will be file exists test. So we create a directory that we'll be working in. Okay. Now what? Should return true if existing directory. We're checking for okay. So test should return true for existing file when checking for absolute path. Okay. Very long name, but we'll live. So we start with something like this, but instead of having this whole directory, okay, we'll just keep it path from the beginning. And the same thing here. A little bit more generic. File1 path. File1.txt. Or let's do PDFs here. Why not? So instead of create directory, we need to do FileSystem create file. Okay. And we just give it the absolute thing. And then, yeah, we can just check if it exists. And that's for absolute paths. But let's also do that. We save the file. And we also check file.exists. And that should return true as well, right? The question is, should we test this separately or at the same time? Because we have the exists defined here that just calls it. I guess we should. We should do it in one place because both places should, are considering the same and considered the same basically code, the same functionality, and all exists and remove. They will be just shortcuts so that you can use the handle first without, calling to the file system every time. So I'll check them at the same time, all right? That should work. Then another one should be the test should return true for existing file when checking for relative path. Okay, we'll do that. This will be file 2. And create the file, right? And for both should return the same thing. So let's try to run all this. Okay, should return true. Didn't work. Check failed. Huh. Oh, because I'm doing directory exists. File exists. So let me Now let's run it. Oh, first one worked, second one didn't. And it didn't because we need to use the relative path. We need to do FileSystem dot current directory is this, okay? And now it should work. Okay, so our code was right, our tests were wrong, as always. So what else should we consider? Should return false for non-existing directory, and okay, so we do. Test should return false for non-existent file and checking for absolute path, right? We have file 3, this and that, and the file doesn't exist, right? So there's no exclamation mark, not file system, file exists, path, absolute. I wonder if not will be, because we're doing all spaces, right? So if check, and it applies everything here. Then we have not. Would it apply here, or is this gonna go first? I am curious. So if we check if the file exists and should be not, we also need to get the actual file. So that file is FileSystem.create file, and we just give it the absolute path, and we do check not file that exists, and we did second one, which will be also false, but for relative paths. Okay. And we need to remember to switch the whole thing. Which should happen straight here. Check not false system and path relative. Okay. And we even create a file with relative path and everything. Why not? Let's see what happens. Bam, they don't work. Check file, not file exists. Oh. So how does this implementation of file exists work? It's not in here, it's in CommonFS. Yeah, it calls itself with the absolute path. So which ones? Here. So we straight up go file system create file. Oh, not create file. Ugh. Get file handle. Oh, I'm creating a file, then being confused why it exists. There we go. Now it works. Okay, should return false for a file when checking for absolute path. What? Oh, yeah. And if it exists, when we check if it exists for a directory, it will be, of course, false. Test should return false for directory when checking for absolute path. Sure. So we do this and we create the directory. And then if we check this, if the file exists, it should be false. And when we get the directory handle, not directory. File handle for it. Check not file exists. Okay. And why not? We're gonna do another one. Test should return false for directory when checking for a relative path. Okay. Another directory. We create the directory. We set the thing here, and we can check with the relative path. Okay. And we can do relative here as well. Relative path. Relative path. There we go. Everything should still work. What? Top mismatch. Where is it? 45, 18, 45. Relative, path relative. There we go. Okay. All right, another thing tested. We have one more to go as far as I know. Remove file. And we'll have everything tested. That'll be a perfect time to call it a day. So, our test name. First of all, let's commit to git. And test file exists. Test checking if file exists. Okay. And then we can do include files, remove file tests. We will create one like that. Remove file tests. Bam. Oh, and let's make sure it's .nem. So here you can see the removal part. Let's just copy the whole thing. So we have the same start, OS, remove file, and remove file tests. Okay. And we can start copying what we had. I mean, recreating what we had for directories. I should remove a directory using absolute path. So we should have test should remove a file using an absolute path. And let's do the same thing where we have relative and absolute. Test file 1. And this will be .jpeg, okay? And absolute will be that. And therefore we can do the create file that we need to remove, right? So I'll do fs dot create file, and we provided the absolute path. Okay. That file, we have that. Okay. So we can check already. File exists. We need to be sure that the file exists. Then we can basically remove it, right? We'll look on the other one. We check if it exists, and then remove it, and we check if it doesn't exist. So we do fs remove file, and we do directory absolute. And we have to basically do check fs.file exists. Oh, we don't have to. We can do exactly file. Do not file exists. Okay? Because we already tested that they both work the same way. So we don't have to do it the same here. All right. So should remove file with relative path. Exactly the same thing. But we can just do the fs.current directory is this. And remove file. Let's just, why am I getting this directory everywhere? This will be path. Relative. Same thing. Here will be path. Relative. I'll need to go and fix it in all the tests. Okay. Okay. Let's test if the current solution works. Yes, removing file in both ways works. Awesome. So, should remove an empty file, right? If the file doesn't exist, it should be fine. Now, removing files, we already checked that. Here we don't have any recursive stuff, so we don't have to check for all this stuff. We don't care. So it should not throw an error if the file doesn't exist. So test should not throw an error if the file does not exist, okay? We have this thing. We didn't create it. We tried to remove it both ways and it's still good. Okay. We also need to test the whole CommonFS file.remove. Okay. So let me redo some of those tests as we're gonna extend them. So we'll do file1. Okay. And then we're gonna let file2 create a file again. And then we do make sure that exists. And we'll do something where let file. All right, no, we'll do file2.remove. Okay. Well, let's just put those here because it looks prettier. And check not file2 exists. And that's it. So we have, we tested both files. We should have basically the same thing here. File1. And we can actually move this whole thing here, and this will be path relative. So we have file1, file1, file1. And then we can do file2. Create file. Okay. Check if it exists. File2 remove. And there we go. So it should not throw an error if a file doesn't exist. And we'll do basically both for absolute and relative. And then we'll also do let file is fs.getFileHandle. And we do path absolute. And we do, what is it? File remove. Okay. And no exceptions should happen here. Okay. Progress. Although here with relative, we need to suddenly make sure the current directory is this for it to work. And here we created with absolute path, so we don't care, and we can just remove it. Okay, good. All right, and should throw an error when trying to remove a file. So here it should be should throw an error if the file, if the path points to a directory. Okay. So we create that directory. And we don't care about that. We just expect, what was it? Catchable? The hell was the error? Catchable error, okay. So yeah, we have the directory, right? And then we're gonna basically try to FileSystem remove file and path absolute. We don't care about relative here, I guess. Okay. And we should have the same thing. Expect catchable error when we do file remove. Okay. We just need to do the let file is get file handle to the thing. Yeah. Let's try to run it. Error. Invalid indentation. That means I did some boo-boo somewhere. 60. Oh, missing colon. There we go. Everything works. We're done testing, at least the basic functionality. And I like how you know, the flexibility of using it. So far, it's awesome. You know, we do file remove, but I might as well do remove file, right? Hey, that's awesome. Remove file. I like it. Remove file and awesome. Okay, so let's comment this. Okay, and this will be test file removal. Push it. And okay, this whole thing starts to take some shape. So it's very exciting. So let's just recap what we have already done. So we have all the directory creation, checking and removal. We have creating, checking, and removing files as well. And we have the handy get file handle so that we can call those, you know, file.remove exists and whatnot. And we need to create the same thing for a directory to get like a directory handle, because I really like that flow, at least that option. And this is something that if somebody makes an implementation of the abstraction, they don't have to code it themselves. It just works. And we have the operations for getting and setting the current directory. And I really like it because we can work with those relative paths really easily. And, you know, again, the whoever implements the abstraction doesn't need to worry about them. They operate just on absolute paths, so it's awesome. So what can we do next stream, which will be Friday? As we just read the stream earlier about iterators, how about we implement that? We'll implement iterator that we can walk the directory. Okay, so this will mean that we go through the whole you know, all the files and directories inside the specific directory. But what does it mean that we walk through it? What are we getting from it? We're getting file paths or like paths or what is happening? That's something we'll need to check, because we could handle it. We could handle it in 2 ways or 3 ways. one way would be where we just get paths, just random paths for whatever we're walking through, which is kind of pointless. Second option would be to return respective file or directory, right? We would need to create the directory. And that means that for each one of them, we could actually take some actions. You can get a path, you can get a name, you can get something, you can, I don't know, move, copy, whatever. So that would be really handy. And a third option would be that we return something like file info. But that would be, I'd say that would be a little bit stupid, a little bit pointless. Not sure that's a good idea. So I think it will be return iterate over instances of dir and file, okay? Because I think that will be really handy. Oh, we're already in code, okay. And walk directory recursive will be basically the same thing. It's just when we encounter a directory, we just iterate over that. And suddenly we'll need to figure out how are we handling when we got into a directory and then it turned out to be empty. We just go back and, oh, hey, here's the handle of the directory because it's empty, or what? Interesting. It'll be interesting to figure that out. So iterate over instances of dir and file recursively. Okay. So that would be pretty fun to implement and probably not fun to test, but that's something that we'll definitely need to test to make sure that everything works. And if we'll be implementing a directory, that means, you know, that directory object, whatever. That means we'll need to probably write, you know, checking for existing and removal for directories. And that means we'll need to add a few lines in our test as well. Okay, so when we have that, we'll need to decide if we want to start implementing getting file info. You know, like, hey, what's the last notification time? What's the last creation time? All those fun things. Or if we want to start implementing reading to a file, writing, I guess reading from and writing to will be a little bit more important because this is functionality, like, you know, that's the whole idea of creating abstraction like that, not like, you know, what we're doing. So we might, you know, do something like that first and then just add some extra little things to the file handle where we can get some info out of it. Because I think instead of just get file info, we could just attach it to the handle and do everything through that instead of, you know, a million extension methods or whatever. Or both. I don't know. We'll see. We'll see. We'll figure it out in the next few streams. Yeah, and later we can play with those. Ugly permissions. All right. So I guess that'll be it. And thank you for watching. Most of people who watch it will be watching after, you know, I finish streaming. So again, thank you for watching. Like and subscribe. You can still write in comments with suggestions, questions, or whatever. I can leave you a question. Hey, do you want, as you know, I'll be tackling a little bit of game development as well. Should I go with Godot and C#, or should I go with Unreal Engine and possibly Nim? Because I know there's a decent extension for, or like decent plugin so that allows you to write code in Nim and actually do most of the stuff that C++ can do. So, you know, that's an option. Let me know in the comments or whatever. And again, thank you for watching and see you on Friday.